Good morning, class. I was just down there. Hope everyone is doing well today. We're just going to jump right into our next lesson. I'm going to give you that 10 minutes to work on your student booklets. So use that time. Make sure you're turning in your verses right now. If you did not do them, you're not supposed to be doing them right now and then turn them in right now. I'll give you guys that 10 minutes to work on your student booklets in the reading. Make sure you're reading it, and then we will jump into the lesson. So I'll give you about 10 minutes, and then we'll be right back. Welcome back. Hopefully you were able to get a lot done there. It's not going to let me move that right now, but we'll just leave it. Hopefully you can hear me. Hello, hello. But we're just jumping right in where we left off. Remember, this lesson we're talking about is more informational. We're not going to get much into depth on that part. Where's my screen? There we go. But remember, we're talking about the geographical and political situation of the time of Christ, where Jesus was most of the time, which was Israel. We talked about the size of Israel, right? How it's small. It's only 30 to 80 miles wide, so it's not very big at all. It is roughly the size of Massachusetts and Connecticut combined. You see, it doesn't even compare to Nebraska or Kansas. Then we talked about the location, the area it's in, right? It's kind of in that Mesopotamia area by the Dead Sea, and then Egypt, Asia Minor, Assyria, and Babylon. At that time, remember, those were the main areas that were populated and talked about in history, so that Israel was considered the center of the world. But not only did we talk about the size and location of Israel, we talked about some of the physical features of Israel. It was considered a perfect country, right? It varied in climate. We had nice weather, hot weather, and we had cold weather, very close to each other. We had the mountains that would snow. Jerusalem, there would be snow. But then you had the Dead Sea where you could always, the sun would always be out. Then we see a varied geography. Remember we talked about that? Again, we have mountainous regions, but also we have the Dead Sea and water and more like a beach type, well, it's more rocky, but kind of a beachy landscape. And these would be within, we talked about how we have Mount Hermon, which is about 9,300 feet above sea level, and the Dead Sea, which is about 1,300 feet below sea level, right? That highest point to the lowest point in Israel, and these were only about 200 miles apart. Okay, talk about varied climate, varied geography, and then varied crops. Remember, we talked about how it had the world-famous Jaffa oranges and bananas, but it also had many other produce, such as grape, cucumbers, and almost any type of vegetable imaginable. Okay, today we're going to talk about the political division of the land. The political division of the land. There's three major areas that separate the political division. Within Israel, there's three different areas that had a different stance or a different political stance or belief through Israel. We have the political division of the land, and we had three major areas. We had Judea, we had Samaria, and we had Galilee. These are the separations or the cities or areas that we separate, or how it was separated politically. Okay, these are the three major areas. Okay, and we've heard these talked about in the Bible. All right, we have the land of Galilee. We know Judea, and how even in old times the kingdom of Israel was split up into two separate parts. We had Israel and Judea. And then Samaria, those were considered like the half-breeds. They despise each other because they weren't fully Jewish nor anything else. But not only do we see these three major areas, but there were also, during the time of Christ, remember, who was in control? Rome, remember, they were the ones kind of the conquerors of the land, of the world at the time, and so they were in control of a lot of things. So we see different Roman provinces, okay? Those are the three major areas, but we see, not three, but a few different Roman provinces. That's what we're going to talk about. We see the political division, okay? We see these Roman provinces. The first Roman province is Judea and Samaria. Judea and Samaria. During Christ's time, 7 different men ruled this area. It is an area of broken hills and valleys. It is good for grazing herds and flocks. The city of Jerusalem was a natural focal point of the area. Okay, so you have this Judea, Samaria area. As it says, it's a lot of broken hills and valleys. So maybe if you want to mark that by in your notes or something. So you have Judea and Samaria. You could put broken hills and valleys. It's good for herds and flocks, or good for those type of animals. And the city of Jerusalem was a natural focal point of the area. So those are some things maybe to note yourself about Judea and Samaria. The second Roman province was Galilee and Perea. Galilee and Perea. This is where Herod Antipas, he ruled this area. During biblical times, the area was heavily wooded. So maybe lots of trees or lots of brush. It is well supplied with water from 25 inches of annual precipitation and runoff from Mount Hermon. So the soil is very rich and fertile. Okay, so they would get maybe some rain there, but they would get a lot of drainage, remember, from that Mount Hermon. Mount Hermon, they would get a lot of drainage from the snow and stuff, so this would flood their area and their land, which would create a very soft and fertile soil so they could grow lots of things. Okay, so those are some things you don't want to mention for Galilee and Perea. You put Herod Antipas, he ruled this area. It was heavily wooded. You could say runoff from Mount Hermon made the soil very rich and fertile. The next Roman province we're going to talk about is Etruria and Trachonitis, okay, which is known as Northern Galilee. Okay, we have Etruria and Trachonitis. This is Northern Galilee. Philip ruled this area. Trachonitis was located northeast of the Sea of Galilee. Okay, because of the Etrurians were nomads, or wanderers, as we know nomads, they're wanderers, it is difficult to specify precisely where Etruria was. Okay, so this province of Etruria and Trachonitis, Philip, he ruled this area, but it was Trachonitis, we know, was northeast of the Sea of Galilee, but the Etrurians, they were hard to locate. They're wanderers, maybe shepherds, people that didn't stay still. So this is a Roman province, but maybe it always wasn't in the same area, as they might have moved place to place. Fourthly, and lastly, we have Decapolis. Decapolis. This is the fourth region. Although not officially a Roman province, this area, Decapolis, was under Rome's partial control or influence. It was comprising 10 Greek cities. That's why it's called the Decapolis. Okay, Deca meaning 10, polis or opolis meaning city. Okay, so Decapolis kind of makes sense, is an area or province of 10 cities, 10 Greek cities. Coins of these cities were often stamped with words that indicate that they were, at least to some extent, autonomous, independent, sovereign, or dedicated cities. Okay, so cities that ruled or were on their own. Okay, so we see coins of these cities were often stamped with words to indicate that they were, at least to some extent, autonomous or independent, sovereign, or dedicated cities. Okay, they were to themselves. Although it's considered one province, each city considered them their own. And they did this by coins and stamping their coins. Okay, I think that's basically all we're doing today. Remember, it's just informational, okay? It's going to be a little bit different of a lesson. But that's okay. We're just going to be getting through that. But what I do want is I want you to pull out your Bibles. Pull out your Bibles. And turn to John 1, 1 through 3 again. Turn to John 1, 1 through 3. I want you guys to read it along with me. You don't have to read out loud, but read along with me. You should pull out your Bibles. Those should be out. And we're going to read through our verses for this week. Okay? And it begins saying this, John 1:1. In the beginning was the Word, and the Word was with God, and the Word was God. The same was in the beginning with God. All things were made by him, and without him was not anything made that was made. Okay, we've talked about how God, and I'm sure you've learned, most of you as growing up, whether coming to this school or if you're familiar with the Bible, that God is our creator. He is the Alpha and Omega. He is the I am. He has no beginning and he has no end. And this just tells us about how much and important and strong God is, but also how important and strong his word is. And I kind of went over that yesterday, but I just want to make it a reminder, okay? God's word is very important. It's something that's been here for forever. It is part of God. It's his words given to us to allow us to have something to give us guidance and instruction in our lives. And how foolish it would be for us not to be able to at least spend a little time in it, to be able to learn and grow and know what God has for us. So that's just something I want to challenge you with. I'm going to challenge you all week until we have that verse quiz on Thursday. Remember, the verse quiz is John 1:1-3. I'll try to make that fill in the blank a little bit, so give you a little help. It shouldn't be too hard. The verses aren't that hard. Make sure you turn in your homework again. Is write your verses 3 times. The rest of class, what I challenge you is to open your Bibles. Okay, so you have to do this. This is what I'm assigning. Okay, you can't just go do whatever you want or other homework. I want you to open your Bibles, and I want you to turn to Proverbs 1. Proverbs 1. Okay, and like I said, okay, you guys come. We have Bible class. And I've been there. Like you think, oh, I got Bible today, but remember, we need to get into the Bible and read it in our own time. Maybe try to understand it in our own time. Okay, so I want to challenge you to read Proverbs 1, verses 1 through 8. Proverbs 1:1-8. Okay, I want you to read it. Don't rush through it. But I'm assigning this. This is just a little classwork. Okay, we're done with the notes for today. Again, we're just doing a little more informational stuff this week. So I want us to be able to still get things that we can apply to our day and to our week. So Proverbs 1:1-8. Hopefully you can get something there from those, something that we could learn individually and as a class. But I'll be down there in a little bit, and we will be done for Bible today. No homework. Work on that booklet. Remember, those booklets are due Thursday as well. Don't want to miss out on those grades because those are worth two grades, so those are easy to get your grade up. Verse quiz on Thursday, and we still have quiz on Friday. We'll be done with Bible. Next hour, we'll be reviewing for our tests for government. So distant learners, if you have any questions, let me know. Those in classrooms, we will be reviewing for our tests. But okay, go and read that Proverbs, those first 8 verses. Try to get something from that, and I'll be down there in a couple minutes. All right, class. Pull out a sheet of paper. Tomorrow we've been mentioning, we finished our notes yesterday, but I had mentioned earlier that we have a test. I mentioned that yesterday as well. We have a test tomorrow. Okay, so you're going to want to pull out a sheet of paper, write this stuff down for a study sheet. I would recommend that because what I do, if you make a study sheet, it can't be your exact notes, and it can't just be like half a page. It has to be at least a page. Probably 2 would be best. But if you make a study sheet for the test, you can get up to 3 bonus points on your test. Depending on how much you do, you can get up to 3 points of bonus on your test for doing a study sheet, which will automatically, by doing a study sheet and writing out one, will help you study. Okay, so we're going to review real quick. If I was in the class, we would do a game and stuff. Obviously, I'm not right now. So we're just going to kind of run through some stuff. I'm not going to say it's slow enough for you to write down everything. So write down something that will maybe help. So like the question, I won't ask in the exact order how it's asked. But if I said, what is when people rule directly by popular vote? What is that? Okay, and I say the answer is direct democracy. Okay, when people rule directly by popular vote, that is direct democracy. Okay, you could write down, okay, term I have to know, direct democracy. And then tonight for homework, you can write a definition out, and that's a start to a study sheet. Okay, maybe that's how I would say to do it. But that's what we're going to do today. Pull out a separate sheet of paper. I would recommend that. If not, I mean, it's up to you. There's no reason to get less than a B on the test tomorrow with the information I'm going to give you. Okay, there's no reason for it except laziness. Here we go. Okay, so again, it's over chapters 1 through 3, everything we've gone over. I'm just going to run through a lot of the test. I'll tell you section by section what it's through. I'm not going to ask it in 100% order, but I'll tell you exactly what's on it. So first I'm going to tell you the order it comes in, okay? So you have 1 through 10 is matching. You're going to have some matching on that one. Some terms that's in that one, or that is in that one, is terms like know what socialism is. Know what socialism is, right? Socialism is an economic system in which the government controls the nation's resources and its means of production, right? So socialism is when the government has complete control over everything, over the resources, over production, over what you're going to do with it, all that stuff. That's socialism. Pretty much you're going to want to know what all the different things are, from absolute monarchy, right? That's when a ruler exercises unlimited authority and usually inherits his position, right? Absolute monarchy, he's given it through his family line, and he has absolute power. So that's absolute monarchy, not anarchy. Monarchy. And that's the ruler exercises unlimited authority. You don't want to know all those, though, so you don't want to find them in your notes, highlight it, do something. Absolute monarchy, autocracy. Remember, that's when a ruler is limited by a constitution. Constitutional monarchy, right? If absolute monarchy is when a ruler exercises unlimited power, right? He's not held by anything. Constitutional monarchy would be a ruler that is limited by what? A monarch that's ruled or under what? A constitution would be a constitutional monarchy. You have autocracy and theocracy, right? Know what those two things are. Autocracy is when we rule ourselves, or we're ruled by our one self. Theocracy is someone or a nation or something that's ruled by God. Know the difference between those, autocracy and theocracy. Know the difference between direct democracy and indirect democracy. Direct democracy and indirect democracy. Direct democracy is when the people rule directly, right, by popular vote. That's direct democracy. I think I mentioned that one already. But indirect democracy is when people rule indirectly. So pretty common sense. People that rule directly is direct democracy by popular vote. People that rule indirectly is when people rule indirectly through elected representatives. Okay, pretty common sense on those. You don't want to know the difference between know what totalitarian dictatorship is, right? It's when a dictator controls all aspects of society. Know the difference between that and socialism. It is a little different, very similar, but a little different. That's a good start. Okay, the next section in the test is going to be a short answer. 11 through 22 are all short answer. Okay, so you're going to have questions like, again, I'm not reading all of them, but questions like, trying to find a harder one that maybe you wouldn't know. These ones are pretty easy. Like this one, name the totalitarian dictatorship in which all power is vested in one ruler. So what is it called when totalitarian dictatorship in which all power is vested into one ruler? What is that called? What is the belief or idea of that called? Remember, it's fascism. Fascism. Okay, know what fascism is. Okay, we talked about a specific work ethic. A specific work ethic that is the idea that work is a gift from God and a means of glorifying Him. What is that work ethic called? It's called blank work ethic. Okay, so it should be pretty easy. So what is the idea that work is a gift from God and we use it to glorify Him? So if work is a way to glorify Him, then we have a Puritan work or Protestant work ethic. Okay, Puritan or Protestant work ethic. Know what that is. Another question, I'm not going to give the answer. In what verse are success and prosperity promised to the person who will meditate upon the laws of God and obey them? Okay, that might even be a question in one of your quizzes. So remember, use those quizzes as study sources as well. We should know that. We should know that already. Know the Ten Commandments. What's another word for them? Know which amendment. Know which amendment to the Constitution is the separation. Remember, we're talking about separation of church and state. Which amendment is that? Okay, remember when we were talking about Parliament? Parliament, at first we said it had three categories with nobles, clergymen, and then like slaves, right? Kind of like separating that a little bit. What were the two houses? Remember we were talking about how there's an upper house and a lower house in Parliament. What were those two houses' names? What were the names of the two houses? The upper house is what? Lower house of Parliament is what? Okay, should be pretty common sense. Okay, if the people, we have nobles, clergymen, and like the slaves or the low class, right? You have two, the upper house, which is like that nobles and clergymen, is the House of Lords. Okay, upper house, House of Lords. Lower house is House of Commons. Okay, pretty easy, I think, to remember those. Okay, again, I'm not going to give you all the answer for this one, but what document, for the first time in English history, placed the king under the law of the land? Okay, this was an important document we talked about that took away the absolute monarchy or power from the king and made the king be under the law of the land. A question we had on one of our quizzes, and I'm pretty sure it was in your homework as well, but what was the first representative assembly in the colonies? What was the first representative assembly in the colonies? Remember, it's the House of what? Starts with a B. Again, I'm not going to tell you the answer, but you don't maybe want to write that term down on that blank sheet of paper I told you to pull out to start your study sheet. The House of what? We should already know what a county is. A county is a local unit of government in the southern colonies. A county is a local unit of government in the southern colonies. Okay, pretty easy so far. Those are all the questions. Actually, those are all the questions for the short answer sections on this test. You have some multiple choice questions on here as well. You don't want to know what, so you could put what word equals, or you could put this quote, but what word means our loyalty, our support, and our devotion to duty. Okay? When we have loyalty and support and devotion to our duty, that we have what? Or we pledge what? That means we're giving our what to that thing. So what word means one's loyalty, or our loyalty, our support, and our devotion to duty? Okay, then we have, you don't want to know this. What is represented above the head of the Chief of Justice of the Supreme Court? Okay, in the Supreme Court, above the Chief of Justice or Chief Justice, there's something above his head. We talked about that. What is that? Okay, I'll give you the answer for that one. That's the 10 Commandments. So you don't want to know that one. What is represented above the head of the Chief Justice of the Supreme Court? It's the 10 Commandments. Know what heritage means. Know what heritage means, what it describes. Know what heritage means or what it describes. Who said this quote? Okay, this one should be pretty easy. Who said this quote? Ask not what your country can do for you, but ask what you can do for your country. Okay, who said that quote? Ask not what your country can do for you, ask what you can do for your country. Who said that quote? Which man or president said that quote? Okay, question I'll answer. Which monarch, we talked about different absolute monarchs, which one was not, or the question asked, which of the following was not an absolute monarch? Know that Francisco Franco was not an absolute monarch. So know that Francisco Franco was not an absolute monarch. Know what the price of socialism is. Know what the price of socialism is. Know what the cornerstone of American government is. We talked about the cornerstone of American government is this. Know what the cornerstone of American government is. We should already know this one, but what was the greatest influence on the English nation? What was the greatest influence? Okay, pretty easy. It's no law or anything we wrote, but it is what God wrote, right? God is the greatest influence, so it's the Bible. That one's pretty easy. Know what common law means. Know what common law means. Know what became the model for colonial legislators in America and for the U.S. Congress? So what became the model for colonial legislators in America for the U.S. Congress? Well, what became the model of that? We should know that one, right? What was the Great Awakening? Remember, it was an event that had immeasurable effect upon the unity of the colonists. Remember, it brought them together. It was bringing them together by morals based upon the Bible. It helped, and remember, it also helped prepare them for future political, economic, and religious liberties. Remember, that was the Great Awakening, led by two men. So you probably want to know those men as also. Remember, we talked about a specific man. This guy was one of the people on Parliament. Okay, remember how there were people that were the king's friends. They helped the king and what he wanted, his agenda or their own agenda. But there was this one guy. There's two, but there's this one guy, his name, that stood up and was in Parliament and stood up for the colonists. He was the one who supported American colonists. We took a little extra time to talk about him. Remember who that was. Remember, that was Edmund Burke. Know the difference between all the acts. We talked about, I believe, 3 or 4 different acts, right? The Stamp Act, Intolerable Act, the Prohibitory Act, and the Albany Act. Okay, know the difference between them. One question is to ask about one of them. Know the difference between them. Okay, we're almost done. The test is almost done. We have a few more, two more sections, and then an essay. And then we'll be done for the class, and you guys will have that study sheet for you. Okay, so we have, again, going over it again, we have some matching, 10 questions on matching. We have like 10 questions on short answer. We have about 13 questions on multiple choice. We have some modified true and false. You've had these, I believe, in some of your quizzes. Some modified true and false, where if the answer is true, you write true. If it's false, you don't write false. You write the true answer that would take the place of the bold or italicized term. Okay? So with that, you're going to want to know what patriotism is. Remember, patriotism is the love or a love for one's country and a loyalty to that country. Remember, patriotism is a love for a country and loyalty to that country. Patriotism. Know which was the first foundational civil ordinance. Okay, we talked about what was the first foundational civil ordinance, or that brought structure. It was given of God. Remember, we talked about that. Know what the Mayflower Compact is. The Mayflower Compact, we talked about that, I believe this chapter is actually somewhat recent. Remember, it was a covenant under God to establish a civil body politic. Okay, remember the Mayflower Compact was a covenant under God to establish a civil body politic. Know the difference between unicameral and bicameral. Remember, one is only pertaining of one house. The other one's pertaining of 2 houses. So know the difference between unicameral and bicameral. Okay, so that's the true and false, some of the stuff that's in there. And then we have to end, not quite to end, but the last section, which is matching, another set of matching, and this is going to be over a bunch of people. Okay, so I'm going to give you I'm literally going to give you every name that's on here specifically. I'm going to read every name specifically. Okay, you're going to have to go in your notes, write your study sheet so you can get bonus, and write what these people did or who they were in the notes or reading. Okay, first we have Francis Bellamy. Francis Bellamy. Then we have Henry II. Henry II. Then we have Karl Marx with an X. Karl Marx. Then we have Francis Scott Key. Francis Scott Key. Know who these people are or what they did. Francis Scott Key. Know Edward I. Edward I. What did he convene in? Know who Daniel Chappie James was. Remember, he was the first African American to become that 5-star general. Daniel Chappie James. Know who Queen Victoria was and what she did. Queen Victoria. You're going to want to know William Blackstone. William Blackstone. Remember, he wrote the commentaries on the laws of England. Remember, he gave his philosophy or what he thought should be the stance or what was the purpose of the commentaries on the laws of England. That was William Blackstone. You're going to want to know Thomas Jefferson. Remember what he did, right? He was part of an assembly or group of men, smart men that put their minds together to write what? And he was the main author of that actually wrote it. But what did he do? And lastly, Vladimir Lenin. Vladimir Lenin. Vladimir Lenin. Okay, that's all the sections on the test. The last thing on the test, there is an essay. Okay, I'm going to read the essay word for word. Okay, I'm going to read the essay word for word. So you can write down the essay. You can either find your answer tonight, memorize your answer, or you can just look over the question and then make sure you know like a solid answer to put on there, okay? The essay's worth 6 points, okay? So it can't just be a quick answer. You're going to have to put some good content in there that I'm looking for, okay? But here's the question. According to Romans 13, 1 through 7, according to Romans 13, 1 through 7, how should a Christian respond to civil government? So according to Romans 13, 1 through 7, how should a Christian respond to civil government? Okay, that's not it. That's the first part of the question. Secondly, relate your answer to what a Christian's responsibilities toward government should be. Okay, so first we have according to Romans 13, 1 through 7, how should a Christian respond to civil government? So I'm looking, maybe what does Romans 13, 1 through 7 state? Give me a quick tidbit from that quote from the Bible as best as you can that talks about civil government, how it says that we should deal, how the Bible specifically says we should deal with it. Then after that, give me your opinion what that means. How does that apply to us? Relate your answer to what a Christian's responsibilities toward government should be. Okay, that is the essay question word for word. Hopefully you wrote that down and you can prepare. Okay, that is the test. That's our whole test. We covered not all in order and not exactly how it's presented, but we covered a lot of the stuff that's on there. Not everything, but a lot of it. There's no reason, if you guys study that, make that study sheet to get a little bonus. But make sure, if you study it, I promise you, if you study and you actually apply, you can't come in and if you say, oh, I studied, I looked over it for like 5 minutes, and I didn't get a B, Mr. Coral, well, you didn't apply yourself. If you apply yourself and you study the content I just gave you, there's no reason for someone not to get at least a B. Okay? I'll be down there in a little bit. Distant learners, if you have any questions, let me know. Make sure you're saying that you're here when you're here, so we can know you're here. It looks like I only have one extra viewer at one of the classrooms, so it looks like someone's not here. Make sure you're always saying if you're here. Both Christians, make sure if you're live streaming, make sure you say, hey, just here, or say something so we know you're here. We can put you as here. If not, we have to mark you as absent. So remember that. Even if you're distant learning and you say you watched it, we'll have to mark you as absent because you did not let me know. Okay, so if you have any questions, let me know. Distant learners, I'll get those tests to you today. If I haven't sent them already, I don't think I have, so I'll send those today. And then in the classroom, I'll be down there for any questions in a minute. All right, we'll see you soon. Let me know if you have any questions.
All right, welcome to chemistry. We're going to go ahead and get started. We're going to get started today actually with a video. We got to that blue box yesterday, and I have a video of him actually going through and saying this, and this is actually a longer snippet than what was in that blue box of Understanding Quantum Mechanics by Feynman. And so this is actually the opening to the lecture, and this is where he says that statement. So I felt it better to, instead of me reading it, instead of me telling you what he said, to just hear it from him himself. Now, I'm hoping this works, hoping it comes through, because we haven't done video with these setups yet. I know the video should come through. I think I've got the audio piped through correctly, and then hopefully everything's synced, because I have no idea. So we're going to try it, and I'm also hoping this video is old enough to be either considered public domain or that this is fair use for education. I know in the classroom it'd be fine. I'm just worried about YouTube. So hopefully everything works and stays up and we can go from there. Okay, I'm going to give it a shot, and then we'll get into 7.3, which is quantum numbers and electron configuration. So go ahead and get out your supplements now and your textbooks now, and we're going to go ahead and watch this video.
In the beginning of the history of experimental observation or any other kind of observation on scientific things, it's intuition, which is really based on just experience with everyday objects, that suggests reasonable explanations for things. But as we try to widen and make more consistent our description of what we see, as it gets wider and wider and we see a greater range of phenomena, the explanations become what we call laws instead of simple explanations. But the one important odd characteristic is that they often seem to become more and more unreasonable, more and more intuitively far from obvious. To take an example is the relativity theory, in which, for instance, the proposition is that if you think that two things occur at the same time, that's just a subjective opinion. Someone else could conclude that those two events, one was before the other, and that simultaneity is merely a subjective impression. Now, there's no reason why this should be otherwise, really. The things of the direct everyday experience involve large numbers of particles, or involve things moving very slowly, or involve other conditions that are very special and represent, in fact, a very limited experience with nature. It's a small section only that one gets of natural phenomena from a direct experience. It's only through the refined measurements and careful experimentation that we can get a wider vision. And then we see unexpected things. We see things that are far from what we would guess. We see things that are very far from what we could have imagined. And so our imagination is stretched to the utmost, not as in fiction to imagine things which aren't really there, but our imagination is stretched to the utmost just to comprehend those things which are there. And it's this kind of a situation that I want to talk about tonight. Start, for instance, with the history of light. At first, light was seen to behave, it would appear to behave very much like a rain of particles, of corpuscles, like rain. Bullets from a gun, same idea. Then with further research, it was clear that it was not right, but that light actually behaved like waves, like water waves, for instance. And then in the 20th century, on further research, it appeared that light actually behaved in many ways, again, like particles. In the photoelectric effect, you could count these particles, they're called photons now, and so forth. Again, electrons, when they were first discovered, behaved exactly like particles, bullets, very simple. Further research showed, in electron diffraction experiments and so on, that they behave like waves. And as time went on, there was a growing confusion in the question of how the things really behave, the waves or particles or waves, because everything looked like both. Now, this growing confusion was resolved in 1925 or 26 with the advent of the correct equations for quantum mechanics. And now we know how the particles, how the electrons and how light behave, but what can I call it? I can say they behave like a particle wave, or they behave in typical quantum mechanical manner. There isn't any word for it. If I say they behave like particles, they give the wrong impression. If I say they behave like waves, they behave in their own inimitable way, which technically could be called the quantum mechanical way. They behave in a way that is like nothing that you have ever seen before. Your experience with things that you have seen before is inadequate, is incomplete. The behavior of things on a very tiny scale is simply different. They do not behave just like particles. They do not behave just like waves. Atoms do not behave like weights hanging on a spring and oscillating, nor do they behave like miniature representations of the solar system with little planets going around in orbits, nor does it appear to be somewhat like a cloud or fog of some sort surrounding the nucleus. It behaves like nothing that you've seen before. Well, there's one simplification. At least electrons behave exactly the same in this respect as photons. That is, they're both screwy, but in exactly the same way. How they behave, therefore, takes a great deal of imagination to appreciate, because we're going to describe something which is different than anything you know about. This, in that respect, at least, makes this perhaps the most difficult lecture of the series, in the sense that it's abstract, in the sense that it is not close to experience. And I cannot avoid that. Were I to give a series of lectures on the character of physical law, and to leave out from this series the description of the actual behavior of particles on a small scale, I would certainly not be doing the job, because this thing is completely characteristic of all of the particles of nature and is a universal character. And it is, if you want to hear about the character of physical law, essential to talk about this particular aspect. So it will be difficult. But the difficulty really is psychological and exists in the perpetual torment that results from your saying to yourself, but how can it be like that? Which really is a reflection of an uncontrolled, but I say utterly vain, desire to see it in terms of some analogy with something familiar. I will not describe it in terms of an analogy with something familiar. I'll simply describe it. There was a time when the newspaper said that only 12 men understood the theory of relativity. I don't think there ever was such a time. There might have been a time when only one man did, because he's the only guy who caught on before he wrote his paper. But after people read the paper, a lot of people kind of understood the theory of relativity in some way or other, but more than 12. On the other hand, I think I can safely say that nobody understands quantum mechanics. Now, if you appreciate this and don't take the lecture too seriously, that you really have to understand in terms of some model what I'm going to describe, and just relax and enjoy it, I'm going to tell you what nature behaves like, and if you will simply admit that maybe she does behave like this, you will find her a delightful, entrancing thing. So that's the way to look at the lectures, not to try to understand. Well, you have to understand in English, of course. But in any sense, in terms of something else, don't keep saying to yourself, if you can possibly avoid it, but how can it be like that? Because you'll get down a drain. You'll get down into a blind alley in which nobody has yet escaped. Nobody knows how it can be like that.
And again, that's part of a much larger lecture that he gives. And I didn't put the whole lecture in here because shortly after this, he goes into concepts that even went over my head. So he's dealing with, he's lecturing to quantum physicists here. He's actually dealing with people who have been in the field their entire lives. And so this is actually a portion of a lecture series that he gives. And you know, if you take enough time and you just go through and understand it, and I was able to follow quite a bit of it, but I knew a lot of it would be over the heads, and honestly, the whole lecture is nearly an hour, so I didn't feel like showing the whole thing was a good idea, so I edited it down to this. But that hopefully gives you a better idea of what to expect when studying quantum mechanics. And the reason why I like showing that video is entirely because reading the blue box, reading the quote, you can make it sound like this super, like, you know, I don't want to say pious because it's not religious, but a super, like, you know, formal occasion. And you can tell he's joking around with them. He's having a good time. He wasn't a stick in the mud. He was going through and actually just saying, look, we don't get this. Let me try to explain it to you anyway. That was his entire idea. So hopefully you enjoyed that. Hopefully it gives you a better appreciation of what we're talking about. But let's go ahead and go on right now to 7.3, quantum numbers and electron configuration. Now, Schrödinger's equations reveal that electron orbitals are not concentric circles, but instead have complex three-dimensional shapes. However, it is difficult to visualize complex shapes using electron clouds because the dots tend to run together, and making the atom seem to be a featureless blob. For this reason, it is helpful to draw a three-dimensional probability contour around the region that includes 90% of the dots. Okay? The probability contour is done through a lot of math and a lot of computer-generated stuff and stuff we're not going to talk about in this class other than you need to know them. Okay. So, if we do this for the electron cloud in figure A, then we see that this orbital is spherically shaped, okay, in figure B. If we draw a three-dimensional contour around a more complex orbital, we may obtain more complex shapes, and we see this in C and D, okay? Again, these would close completely around, and this would just end up looking like a sphere. This would end up looking like, I don't know, a bow tie surrounded by a ring. So you have to imagine it closed, but we're showing them open to show you guys what's actually happening. The Schrödinger's equations reveal that some orbitals are shaped like dumbbells, while others are shaped like clover leaves, donuts, or spheres. Nested one inside another, the orbitals produce a very complex region of negative charge around the atom. The complete arrangement of electrons in an atom is the atom's electron configuration. The electron configuration of an atom determines how the atom chemically bonds to other atoms and influences the shape and properties of the molecules that are formed. For this reason, knowing the electron configurations of different elements is important in chemistry. So the Schrödinger equations allow scientists to describe any electron in one atom using four what we call quantum numbers. These four numbers, real quick. Should probably put that on there. The complete arrangement of electrons in an atom is known as its electron configuration. Now, quantum numbers are 4 digits which can uniquely describe any electron in an atom. The 4 numbers describe the electron shell or energy level, the shape of its orbital, whether it be spherical, dumbbell, or cloverleaf, the orientation of its orbital in space, whether it be vertically, horizontally, or diagonally positioned, and its spin, whether it be clockwise or counterclockwise. The fact that even unpredictable electrons can be described mathematically is evidence that the universe is, in fact, lawful and orderly. So let's discuss, first of all, the first quantum number. We call this one the principal quantum number, and it's represented by the lowercase n. This describes the electron shell, also known as the main energy level of the electron, and it's sometimes labeled with K, L, M, N, and etc. So this would be, if n equals 1, it can hold 2 electrons. If n equals 2, it can hold 8 electrons. If n equals 3, it can hold 18 electrons, because the formula we use is 2n squared. Okay, the maximum number of electrons in an electron shell is 2n squared. So not only does it get doubled, it gets squared. Okay, so 3 squared is 9, and then that gets doubled. So as we keep getting further and further away, the bigger the energy level, they can hold more electrons. It doesn't necessarily mean there will be that many electrons in there. It just means it can hold that many. Okay? In general, as the value of n grows, so do the following. First of all, you have the energy of an electron in that shell. The higher out you are, the more energy that electron must have to stay there. Okay? Again, the instance of hydrogen, if you have something in shell 3, well, it's got to really work to stay there because its most stable position is shell 1. However, for some electrons, there's no choice but to be in shell 3 because shells 1 and 2 are full. Okay, so we're going to talk about that more here in just a little bit. But that's, in general, the further out you are, the energy goes up. As the value of n grows, the distance away from the nucleus grows as well. Okay, so the electron will be further away from the nucleus in probability. The number of electrons possible grows, again, duh, And finally, the size of the electron cloud. The higher or the larger the value of n is, the bigger the cloud is, okay? Which just makes sense. Things have more room to spread out. Okay, so that's the principal quantum number. It's our energy level. It tells us how energetic these things are. Now, the subshell quantum number, represented by cursive L, that's actually its own character. We do not use lowercase l in mathematics and science. Looks too much like a 1. Actually, for the longest time, okay, quick trivia. For the longest time, computer keyboards didn't include the character for the number 1. Sorry, typewriters. Computers always have had the character for number 1. But typewriters, many of them came without the character for the number 1, and people just used the lowercase l. Okay, like they had 2, 3, 4, 5, 6, 7, 8, 9, 0, but there was no point in putting a 1 when it looks exactly like a lowercase l. So because of that, both in handwriting and typing, it can look very similar. We actually specifically use the cursive L for the subshell quantum number. So that is the cursive L. This describes the subshell, the secondary energy level of the electron. This is labeled with sp, d, f, g, and then it goes from g. Okay, so it would be hi and so on. We don't normally get that high. Okay, normally it stays within that range there. The number of possible subshells in a particular shell is equal to the principal quantum number. So let me go through and demonstrate this for just a moment before we get too far into this. All right, so let's say I'm at energy level 1. Well, then that means the most subshells I can have is 1, which is 1s. If I'm at energy level 2, I can have energy level 2s and 2p. Okay? By the way, those letters are in order. They're not random. Okay? Those letters are in order. So it's S, P, D, F, G, and then so on. And then you just start going down the alphabet. Go back. Oh, touch is still enabled. You stop that. Okay. Then if I'm on energy level 3, where n is equal to 3, well, then I could have 3s, 3p, and 3d. And then I could have 4s, 4p, 4d, and 4f. Each time I increase my size, I increase the number of subshells I can have. Okay, so hopefully that's making sense. It's not until we get to level 5 that I can actually start using g. And practically beyond this, we're dealing with like nuclear reactions, and we don't want to deal with it. Okay. Because that's already an insane number of energy levels. It does keep going, okay, because we have to have somewhere for really excited electrons to go. But at some point, they'll actually just break free. They'll just break free and create plasma, as we see, in the sun. So at some point, it's just not even part of it. Okay, but that's the subshell number. From there, we give it a magnetic quantum number. And I'll teach you guys how we're going to use all these, but right now we're just introducing them. I know I'm skipping large swaths of text in your book. That's because when you're trying to get something across in print versus just being able to say and draw and do things, you need a lot more words. Okay, so I'm not skipping stuff because it's not important. I'm skipping stuff because we don't need all that. Okay, so if you want to go back through and read it, please do. Okay, that's fine. Some people learn better by reading. But we're going to keep going. So then the third quantum number is the magnetic quantum number, and this is m sub L. Okay, that's its variable, is m sub L. Again, that cursive L. And this describes the orientations in space of an individual orbital within a subshell. This has common values of x, y, and z. So, for example, if I'm talking about the S subshell is a sphere, so we don't, goodness. The S subshell is a sphere, so it doesn't matter which way it's oriented, it's a ball, okay? We can move on. But the P subshell can actually be in 3 different orientations, okay? And so I might have 2p, but inside this 2p orbital, there's the 2px, the 2py, and the 2pz. This is actually very common when doing 3D graphing, to have x and y almost flat and then z up and down. Okay, so just mentioning that. And then if we put them all together, this is the p sublevel. So 2p only tells me this. It doesn't tell me which orientation I'm talking about within that sublevel. Okay, so that's what the third number does. And this would have common values of x, y, and z, at least the way we're going to use it here. These are actually interpreted numbers. You would actually get actual numbers out from the equation and then interpret them that way. But again, we're not dealing with the equations because no, okay, I don't want to deal with the equation. People much smarter than I have figured it out, and we're going to move on from there. Okay, so if we were to take all the orbitals in a shell, by the way, and add them all together, it would look something like this. I think this is just, I actually don't know which one this is, but you have the sphere, and then you have the other orbitals coming around it. And so obviously it doesn't look like these nice, neat little things once in a while, or it's just this. We have all these different types of shapes, and they all exist at the same time over the same center. Okay, and so it becomes looking like this blob. Okay, that's really what ends up happening. And so this is why we need quantum numbers, is to specify where in this blob are we. Okay, we need to pull out this and actually look at what we're dealing with. And all this is going to make sense for why it matters here in a little bit. But anyway, so the third one was our magnetic quantum number. So now we have three levels. Three levels, okay? We have the first one, which tells us how much energy. We have the second one, which tells us its shape. Then we have the third one, which tells us its orientation. And then finally, in each of these, you can hold 2 electrons. Okay, so 2 can fit here, 2 can fit here, 2 can fit here. So 6 can fit in this whole shape. Okay, so now once I'm down to the orientation, now I'm talking about 2 electrons and just 2. How do I tell them apart? Because we said we can identify any electron. Okay, so as I'm narrowing this in, okay, let's consider this. Okay, I've narrowed it down to energy level. Great, let's say I'm in level 2. Okay, let's say I'm at n equals 2. All right, well, that's the first level. Okay, 2 still talks about a lot of electrons. So I'm going to say, all right, well, I'm also in the p orbital. Okay, so it has this shape. So I'm in level 2 with this shape. Okay, great. That shape can be in one of 3 directions. Let's say I pick y for the sake of picking one. Okay, now I'm down to just 2 electrons that I have to differentiate between them. This is where this last one comes in, and we call it the spin quantum number, and that's m sub s. Okay, this is the orientation of the magnetic field of the individual electron. It has values of plus or minus 1/2. Plus 1/2 means clockwise, minus 1/2 means counterclockwise. Minus also means that north is pointing down. Okay, plus means north is pointing up. There will be one of each in that orbital, assuming that orbital is full. Okay, and so we need to be able to differentiate the 2 in that orbital. Okay. What? Give me a second. What in the world? Okay, I have no idea who that is. I'm going to assume it's spam. All right. Now, the reason why all that's important and how we're going to actually use this is because of what we call the Pauli exclusion principle. And that says that no 2 electrons in an atom may have the same set of 4 quantum numbers. So these 4 quantum numbers work together to create a single set where we can identify a single electron in an atom. Now that may seem like it's overkill, it may seem like it's unnecessary, but we need that level of detail so that way we can predict chemical reactions. Now we can do a lot of our chemical reaction prediction using just valence electrons, and as a matter of fact we will for the majority of this class. But once nuclear reactions started really being studied, we needed this level of detail, okay? And so that's where this comes into play. So do I have it? Yes. Okay, this chart summarizes all the stages. It's on page 108 of your textbook. Learn this chart. You need it. Okay? This chart here is going to come in really handy to have in your head, especially come the test. All right, so this chart is really what we're talking about. So again, we have a principal energy level. Okay, so we're going to have 4 numbers that we can represent. So we have n equals, L equals, m sub L, and I hate the fact that they use print here, and then m sub S. Those are our 4 possible quantum numbers. Those are their variables. Okay, so let's say I picked and said, all right, I'm in level 2 with subset P. On the z-axis with negative 1/2. That specifies an exact electron. Now you'll notice the reality of it is P is actually just corresponding to 1. We just name it the p orbital so we don't have a string of numbers. Okay? Technically this is 2, 1, 0, negative 1/2, the one I described. Okay, there's a reason why they're called quantum numbers. We just use letters for everything else to make it make more sense. Okay, so that's the idea. Now, there are 5 basic principles which allow us to describe the electron configurations of neutral atoms in their ground state. What time is it? Okay. All right, let's go with it. The chemical and physical properties of elements are largely determined by the number of electrons contained in the various electron shells. Particularly important in chemistry is the outer shell, which allows the atom to bond with other atoms to form molecules. Electrons fill the orbitals available to them in a very regular way. This behavior can be described by 5 basic principles, which allow us to describe the electron configuration of neutral atoms in their ground state. So, rule number 1. There must be the same number of protons, or a number of electrons, as protons, assuming we're not talking about an ion here, okay? But when we say neutral atoms in their ground state, we're talking about an unexcited atom, and we're talking about there's no charge on it, okay? It's exactly neutral and in the ground state, okay? This means no charge. This means no excitement, meaning no electrons aren't where they're not supposed to be because they got energy from somewhere. Okay? That's the idea. Now, electrons must equal protons. Okay? The number of electrons matches the number of protons. So if you're dealing with, say, oxygen. Okay? Oxygen is atomic number 8. That means there's 8 electrons. Okay? That's how we handle this. Now, we have to obey the Aufbau principle, which means we fill in the lowest energy shells and subshells before we can continue further. You should know what the Aufbau principle is. It's given to you. Then you follow Hund's rule. When a p, d, or f subshell is being filled, 1 electron will occupy each orbital in that subshell before pairing. Here's what we mean by this. We have to fill 1s and then go to 2s before we can get to the 2p orbital. Okay? However, once we're in the 2p orbital, we have to fill 1 in the 2px orbital, 1 in the 2py orbital, 1 in the 2pz orbital. Then we come back through and put the pair in x, y, and z, and then we can move on. Okay, that's the idea. And then we go to the 3s and both just pair right away. Okay, so that's Hund's rule. Only 2 electrons can ever occupy 1 orbital. Okay, that's what I was just explaining earlier. And then finally, the maximum number... Stop it. The maximum number of electrons in maximum number of electrons is 2, there we go, in any S subshell, 6 in any P, 10 in any D, and 14 in any F. Okay? That's as far as we expect you guys to know because, yeah, reasons. All right, so here's how we do this. We tend not to worry about the 3rd and 4th quantum numbers all that heavily in this class. Instead, though, what we'll do is we'll do what's called an electron configuration. Okay? Now, here's the issue we have. The energy levels aren't necessarily in order. Okay? So far they have been, but if I just go 1s squared, then I go 2s squared, then I go 2p, or not squared, sorry, 1s2, 2s2, 2p6, 3s2, 3p6, but then I don't go to the 3D orbital right away because the 4s orbital is actually lower energy than the 3D. So this graph here can kind of be messy, so I highly recommend that in your supplements, you guys copy over this one here, okay? And what you do is you just follow this all the way down, okay? Make yourself a diagonal set. There does exist a 5G. There does, aside from the wireless carrier, wireless band, there does exist 6F, 6G, and potentially 6H, I think. Anyway, there does exist past 7, but again, this is all you'll typically use. So if I were you, I would go through and copy that very quickly. I can't leave it up long, so make sure you guys get it copied. Oh, I'm cutting off the text there. It just says follow the yellow brick road, start here. Okay, this isn't my graphic. That's why there's a citation there. Yay, education and fair use. All right, and then we'll get into actually how to do it. All right, so let's discuss how we find these subshells. If you still need that graphic, remind me and I'll get it back to you guys. If someone reminds me, I'll post the slide itself on Google Classroom. I just need the reminder. So I will gladly do that if you guys need it. But for now, oh, rats, I have to go full screen. No. Yep. Oh, I hate that. If I wanted it before full screen, I definitely want it after full screen. Because then I can take up the whole screen. All right, so first things first, let's say we're talking about silicon. Okay, so then what I'm going to do is on my periodic table, so get out your periodic table so you guys can see what you're doing. I'm going to pull mine up real fast. Oops, I meant that, but all right, that works. All right, so let's talk about silicon, okay? So that's atomic element number 16. We're in the third row down, and so here's how this is going to work. I'm going to start at the top of my periodic table, and you know what? This is going to be a lot easier if I can just import the periodic table. Can I do that? All right, Control-Alt-O. No, I'm going to have to do Control-O. Let's see here. This will just be a lot easier if I can just write on the periodic table for this one. This is chemistry. This one's a horizontal one. Cool. Yep, that's fine. And let me go with a red pen. Let's go blue. Let's make it a little thicker too, because this is going to be a... Oh, that's too much. All right. Okay, so I'm just going to leave the rest because we're running out of time. So let's say we have silicon, which is right here on our periodic table. Okay? So then what we're going to do is, as I'm going through the thing for silicon, I'm going to go through and say its notation. And so I start at the top of the periodic table. All right, and let me go. I'm just going to delete this portion for now. Whoops. Okay, fine. Okay, come on. Why is this fighting me right now? What's Alt? I knew it wasn't. Whatever. Okay, so we have silicon. Okay, it's not that that part of the periodic table is unimportant, it's just not relevant right now. So, starting with row 1, okay, this is energy represented by energy level 1. There's a reason for the shape of the periodic table. Okay, so this right here has 1s1. This here has 1s2. That's the reason for the gap, is because there's only 2. It could be argued that hydrogen has to be here. But there's also argument that helium would have to be over here, so just whatever. It is what it is, okay? So I know I'm going to have 1s2 because that's the s filled, okay? Then I would go through row 2, and so this means I'm at energy level 2. In this block is our s subshell. This block is our p subshell, and then this right here is d. And the part I just deleted is F. Okay? I'm going to remove the F label because we got to go. All right, so 2s2, because I'm using both of them. All right, so I'm through there. I'm going to have a full 2p, so 1, 2, 3, 4, 5, 6. So 2p to the 6th. It's not exponents. I don't know why I keep saying it like exponents, but we're moving on. Then we have 3s2. Notice there's no 3d yet. Okay? And by the way, yes, there is a 3D. It's in row 4. Okay? This is actually 3D. Mentioning that. Anyway, so we're not there yet. We're into 3P. So 3P, and then I'm at 1, 2. I'm at the second one, so 3P2. Okay? Hopefully that makes sense. You guys have examples of the first 20 in your textbook. Let me do one a little bit further. Okay? Let's say I wanted gallium, okay, which is this Ga. Well, then I would have 2p6, okay? And then I would go through 4s2, 3D10, because that's how many are there, and then 4P1, because it's the first one there. Okay, that's how we read this thing. Now, I know we haven't taught the periodic table yet. That's actually the next section. However, we can use it enough to understand how to do electron configurations. I don't have time to do Lewis symbols. I was really hoping to get through it. Okay, so here's the deal. For tonight, you guys had scheduled this section's homework. It was already on Google Classroom. It was ready to go. We're going to postpone that. So it still says it's due tomorrow. I'll look at it. It'll probably end up being due Friday then, because I can't give homework tomorrow. So it'll be due Friday. So I still recommend you guys get started on it, so that way you guys can ask me questions tomorrow. I had a quiz scheduled for tomorrow. That's why I was trying to push so hard today. Yeah, that's not going to happen either. So quiz 7 has now also postponed to Friday. This homework is due on Friday. We're going to spend a little more time talking about electron configurations tomorrow, as well as Lewis symbols. And then tomorrow, Lord willing, I'll go over your guys' tests, those of you who are here in the Distance Learning Center. For now, you guys can know what you got at least, because your grades have been released to you on Google Classroom. Your gradebook in Google Classroom and My School Works are up to date as of this morning. So if you're missing stuff, turn it in. Let me put it that way. So make sure your stuff gets turned in. So I'll deal with the tests tomorrow, and then we will deal with this in more detail tomorrow too. Okay? So hopefully it's starting to kind of make sense. The pieces are kind of starting to work together. I'll try to remember to pick up here tomorrow. As far as the electron configurations, I forgot how dense 7.3 was, and so I scheduled it in a single day. My bad. So we will cover that later. I do apologize that I wasn't able to go over your guys' tests with you today, those of you in the Distance Learning Center. I will throw this out there, whether you're in person or a distance learner, the lesson plans in My School Works now are wrong, because I just made all those changes now, and I haven't had a chance to fix it. So I will try to remember to fix that soon, but in the meantime, follow those changes, where Quiz 7 will now be Friday. Your 7.3 homework will be due Friday. I will try to go in and change all the due dates, but we need to get going. Okay, so I don't want to take up any more of your guys' time, seeing as class is dismissed in like 20 seconds. All right, so I will see you guys. If you guys have questions, feel free to email or text me, but past that, congratulations, you guys get a night without official homework. Like I said, you can do a lot of 7.3 homework, and I highly recommend you do so, because it'll help lock in the understanding, because all these things are deep concepts. So I highly recommend that. But again, no homework tonight. I'll see you guys later.
Hi guys. Let's get into our books. Today we are going to start review for our tests this week. Test on Thursday over test 1 in grammar. Okay, and then quiz tomorrow in literature over pages 30 to 39. Okay, it's over the Canterbury Tales, or 29 to 37, I'm sorry. 29 to 37. It's over the Canterbury Tales and Morte Arthur. We reviewed for that quiz yesterday. So make sure you are studying pages 29 to 37. That is your quiz tomorrow in literature. And then Thursday will be your test in grammar, and then Friday will be your test over units 1 and 2 in literature. So make sure you guys are studying that. Let's go ahead and review for our literature test. Okay, don't have slides for you, but you should have been taking notes already. So go ahead and take out your notes or your book, whatever you need to mark things down. Okay. Go to Unit 1, Anglo-Saxon period. All right. Highlight or star what the first literature of the Anglo-Saxons was. It was poetry, we know that. Make sure you know in Everyman who visits Everyman at the beginning. Well, I guess we're in Unit 1. Let's not go crazy and do out of order. So go ahead and take your books. Unit 1, page number 2. Okay, we'll start at the beginning. Sorry about that, guys. Okay. Make sure you know the literature of the Anglo-Saxons. Okay, the qualities of an epic. All right, the characteristics of Anglo-Saxon literature. Know the differences between those. Know what the differences between an Anglo-Saxon poet is, or a scop and a gleeman. Okay, the scop was the Anglo-Saxon poet. The gleeman was the one who recited or performed the works. And the scop is obviously the one that wrote them. Know what a caesura or a pause is. I'll take either or. Okay, alliteration, kennings, different things like that. Things you should have already known, and because we took a quiz over that. Like I said, the background of an epic, what those traditional qualities are, which is a great national hero, lofty language, supernatural elements, the struggle of good and evil. Actually, for those of you who are on distant learning, please comment that you are with us right now, okay? And then we are studying or highlighting in our books what we need to know for our test on Friday. Okay, know in Beowulf the 3 mysterious and monstrous incarnations of evil, which are Grendel, Grendel's mother, and the fire-breathing dragon. Okay, know who helped him, the characters. Some of you guys said King Hrothgar was the friend of Beowulf who helped him slay the dragon. That was not correct, so know who it was. Okay. In the Seafarer, know just the different, just know the kind of the basic gist of, or not the gist, the summary of the Seafarer. We went over that in class. Okay. You need to know who wrote, not who wrote, but also the different kinds of poems on page 9. Bookworm and Honeymead. Know what Bookworm is talking about and know what Honeymead is talking about. We said that in class, so if you were taking notes, you should know which one is which. Okay? If you don't know, then read over Bookworm and Honeymead. All right? From the Ecclesiastical History of the English People on page 10, know the difference between Venerable Bede and Caedmon. A lot of us are saying Caedmon is from who we get our history, and he wrote the Ecclesiastical History of the English People. He did not write it. It was the Venerable Bede. Venerable Bede, so know the difference between Caedmon and the Bede. Okay, Caedmon is the first Anglo-Saxon poet whose name we know. All right. Know some of the characters in the ecclesiastical history. We know King Edwin and then Coifi. That summary, okay? The story of Caedmon. We talked about all of those in class. Make sure your notes are up to date. Okay, we'll start reviewing that today, tomorrow, and then Thursday. We won't have time to review because Thursday is your test in grammar. Okay, turn to page number 13, the medieval period. Okay, know who William the Conqueror is and how he invaded England from Normandy. Know the different kinds of literature that came out in this medieval period, which is the lyric, romance, the drama. Right? Know the religions, not religions, what is it called? The languages, that's what I'm looking for. The languages that kind of emerged during this period are the languages that were, like their literature was written, so that would be Latin and French. Know who the most notable writer is in the 15th century, which is Sir Thomas Malory. In the 14th century, it was William Langland, Geoffrey Chaucer, and John Wycliffe. But the most notable writer of the 15th century is Thomas Malory. Okay? And know that William Caxton, he set up the first printing press in England. So John Wycliffe was the one that translated the Bible into English. William Caxton was the first printing press, okay? Turn the page to number 14. You guys need to know the differences between a ballad and a carol, all right? Ballad and a carol. We know that popular ballads, they're short narrative folk songs which tell of single, usually tragic events in an objective, unbiased manner. And then the carols, they're kind of sung. They were originally hymns or joyous songs. Okay. Know the plot of Bonnie Barbara Allen. We know that Sir Bonnie Barbara Allen, Sir John, he loved Bonnie Barbara, but then she didn't requite his love. So just know what happened there. Get Up and Bar the Door. Some of you guys were confusing this Bonnie Barbara Allen and Get Up and Bar the Door. So the Get Up and Bar the Door is about the crazy couple who couldn't stand up and bar the door themselves. So they kind of did that bet. The first one to talk has to close the door. Obviously, we know that the man was the first to talk. So he was the one that barred the door. So know that plot. Know the plot of the Cherry Tree Carol. That's the story that's talking about the fundamental truths or the fundamental doctrines of Christianity. Know those fundamental doctrines, okay? So which was Jesus was born of a virgin. Okay, we saw that Jesus is God and has power over creation, and that Jesus would die and rise again. Okay? These all should have been highlighted or something when we're talking about them. So just know the gist of the Cherry Tree Carol and those doctrines. Okay? Let's go over to page 17, Sir Gawain and the Green Knight. Know who wrote this, which is the Pearl Poet. This was the last poem in these poems, or a manuscript containing these poems. Since the first poem was called The Pearl, obviously that's where they get the Pearl Poet. So know that the Pearl Poet wrote Sir Gawain and the Green Knight. Okay, know what holiday that they're celebrating. Okay, so that was New Year's. Okay, Christmas, it does mention Christmas, but that was kind of the background of the story. The holiday that they're actually celebrating is New Year's. So make sure you guys know that. Okay, and then also the plot of that, about the Green Knight, what the challenge was, what happened there, that Sir Gawain cut off his head, different things like that. Just the things that were on your quiz you should have known. You can study those for your test on Friday. Okay, go to page number 24. Know the differences between the mystery, the miracle, and the morality plays. Okay? The mystery plays, they play on biblical subjects. The miracle plays, they deal with the legends of the saints. And then the morality play deals with an allegorical battle, which the vices and virtues wage for the possession of the human soul. So morality, it kind of sticks out to me in the human soul, morality, different kinds of things like that kind of goes together for me. But know the differences between those plays. Okay, and then the characters in Every Man. So the characters in Every Man, the background even gives you kind of the plot already. So we see that death already visits every man, and then know who is the last friend to accompany him to the grave. Okay, that was good deeds. And it's kind of like a metaphorical or allegorical type of setting where it's like good deeds, you can't bring good deeds to the grave. And when you give an account at the end of your life, just like every man did, you can't take good deeds with you to the grave. You can't take knowledge with you to the grave. You can't take other things of this world with you to the grave. And obviously as Christians, if we are Christians, we can only answer to God for our lives by ourselves. And the only thing that will count is what we've done for Christ. So can't take good deeds to the grave, just like this play was kind of depicting. Okay, go to page number 30. Know the background of the Canterbury Tales, what an exemplum is. Okay, it is the example, or an exemplum, which is an example. It's a short tale or anecdote to teach a lesson. It's kind of something that you can remember because if you're teaching a lesson, you like to say, give examples. So an exemplum, which means example, is a short tale or anecdote to teach a lesson. Okay, and then know the lesson of the Pardoner's Tale, that's on page 30, which is the love of money is the root of all evil. Okay, and then know the different pilgrims that we talked about in class. Okay, you don't need to know like what the knight is an example of or the squire, what they're examples of, because we did talk about that, but you're going to have to give some examples of different pilgrims. Okay, and then like I said, the Pardoner's Tale, okay, on page number 34. Make sure you know the story behind that or the moral behind that. We just said it. It's also on page number 30, okay, for you to study for your quiz as well tomorrow. So know the story behind Pardoner's Tale, the summary. We kind of talked about that in class, okay? And then, like I said, the moral, and then what happens in the end, who they were looking for, different things like that. And then go to page number 38 from Mort D'Arthur. Okay, know who wrote Mort D'Arthur. That is Sir Thomas Malory. And then know that this work, Mort D'Arthur, remains an outstanding monument in English literature today. We were talking about and reviewing Mort D'Arthur yesterday. Mort D'Arthur means Arthur's death, or the death of Arthur in French. Talked about the basic lines of the story, the basic summary of the story. So this will be on your quiz tomorrow, and then as well as your test on Friday. So your quiz tomorrow, again, is page 29 to 37, or just page 30 to 37. I'm not exactly going to quiz you over the prologue in Middle English, because it's kind of the same thing on page number 30, which is that prologue in the Canterbury Tales. Okay, if you guys have any questions, please ask. If you need more notes that you haven't written down yet, let me know, and then I can help you. But those of you who are watching Distant Learning, I still haven't seen your guys' commenting, so please comment that you're here with us. And then go ahead and take out your grammar books, okay? We are going, or your workbooks and your handouts. We're going to start reviewing for that for your test on Thursday. Okay. Grammar books and your workbooks and your grammar handouts. And in your workbook, go ahead and turn to page number well, you should have done page 9, exercise 18 for homework last night. So have those out, and I'm going to go check them when I come around, okay? But let us practice page number 17, okay? 17, let's start at the top, exercise 16. Okay, I don't think we did those for homework yet. I think we should have. That was Thursday's homework. Okay, so let's review Thursday's homework. That was page 16 and 17, or page 8, exercise 16 and 17, okay? Let's go ahead and review those. Exercise 16, I'm going to go through these. I think I already did, not going to lie. I don't think I did, honestly. Well, we're just going to go over it again. If I did, then you have these, but if you didn't do it, then you have these. So let's go ahead and go over it. Ready? Exercise 16, prepositions and conjunctions, okay? Upon is a preposition because religion is the object of the preposition, okay? Next line, for is a preposition, okay? It's not exactly linking or joining two independent clauses together, so that can't be a conjunction. It's kind of saying or relating an inward reverence. That's kind of like, it's kind of relating back to inward habitual reverence to I. It's kind of relating those two. And the devotedness to the deity with such external homage, which is preposition. With is your preposition. Either or, those are conjunctions. Those are joining words and a clause. So either or, either public or private, those are joining those together. As the worshiper believes most acceptable to him, according is a preposition. According to, that's a compound preposition. Okay, it is impossible for human laws to regulate religion without destroying it. Without is a preposition. For is a conjunction in the next line. The next line is a conjunction, nor. And then another conjunction in that line is because is joining. Nor can they enforce outward religious homage, and all such homage is either a man's own choice. So because is joining those two clauses together, therefore it is a conjunction. And the next line, and is also a conjunction. That's also joining things together. Any delegation of power over religion, over is your preposition. To public officials, to is a preposition. Okay. Towards the end of the line, by which it was seated, by is a preposition. All right. And then the last line, there's none in the next line. The last line is or is a conjunction, in is a preposition. Okay. Nor can the state or community, or is joining state and community together, therefore it is a conjunction. Okay. Same thing with preposition. In is relating matter to concern or whatnot, so preposition is the word in. Exercise 17, let's go ahead and review those. Reviewing subject, verbs, and complements. These will also be on your test on test on Thursday. Number 1, image is a direct object because obviously Joseph Nipsey or Nipchi, whatever his name is, Joseph Nipchi is your main subject. Okay, would find is your main action verb. However, within that clause or within that phrase, who captured the first fixed image in 1827, image is the direct option or object of who captured. So captured is your verb within that phrase or clause. Who is your subject. Who captured who or what. Image is your direct object. Okay, would find photography drastically changed. Change is the object of the adjective complement. Okay, so Joseph Nipchi is your subject. Would find is your action verb. Photography is actually your direct object to be who or what. Change. Change is your objective complement. if he could see the cameras of today, if he is the subject of that phrase, so he is the subject, could see would be the verb of that phrase. Okay, make sure you guys are looking out for phrases and stuff like that. Number 2, his film was is an action verb, a metal plate. Plate is a predicate nominative because it's kind of renaming what the film was. Film was a metal plate. Okay, number 3, the bitumen hardened wherever sunlight struck the plate. Okay, the bitumen who were what? Hardened whenever sunlight struck the plate. Okay, wherever is part of your phrase. Okay, that would be a subordinating conjunction because that is joining an independent clause to the other part of the other clause in that sentence. Okay, wherever sunlight struck the plate, sunlight is your subject in that clause. Struck is an action verb, so who or what struck? The sunlight struck who or what? The plate. Plate is a direct object. Okay, shadows left the bitumen soft. Okay, shadows is your subject of that clause or independent clause or that sentence. Shadows left who or what? Bitumen to be soft. Soft is your OC. And then the next part of the sentence is Nipsey rinsed off the plate. Rinsed it off the plate. Nipsey is your subject, okay? Number 4, it was Louis Daguerre who improved the process in 1839 by replacing the bitumen with a thin coating of silver. Look at your verb, was, okay, who or what was. It is a subject. It was who or what? Louis Daguerre. Louis Daguerre is your predicate nominative because that is renaming your subject. All right, who improved the process in 1839 by replacing the bitumen? Okay, by replacing the bitumen. Bitumen is your direct object. Okay, with a thin coating of silver. Bitumen, it was Louis Daguerre. Okay, so who improved the process by replacing the bitumen is a phrase within that sentence. Okay, and then who improved is your subject and your verb. The process is another direct object in 1839 by replacing the bitumen. It's kind of crazy because we haven't gone over verbals yet. By replacing is a verbal used as the subject, okay? And then bitumen would be the direct object because that is what was replaced. All right, we'll go over that in a second, but luckily that's not in a second, sorry. We'll go over that next week after our test, but luckily verbals aren't on our test, okay? So we'll explain that more in depth next week. Number 5, most people consider his daguerreotype. I'm sorry if I'm butchering these. I have never seen that before, so looks like you're just going to have to deal with me, okay? Most people consider his daguerreotype the first practical method of photography, okay? People is your subject. Consider is your verb. So his daguerreotype is the first practical method, okay? Method is the objective complement, okay? Daguerreotype would be your direct object, so consider daguerreotype to be the method, which is OC. Number 6, perhaps the greatest breakthrough in film technology was the invention of a flexible film. So breakthrough in that sentence is your subject. In film, was is your linking verb, who or what. Invention, so invention is your predicate nominative because it's renaming the subject, breakthrough. Number 7, this new film could be rolled and stored in the camera. Could be rolled is your entire verb phrase, and stored is your verb. So could be rolled, stored, both verbs, eliminating the awkward process of switching plates after every use. So eliminating who or what, process is your direct object. Number 8, film cameras were common until the digital photography became popular. So film cameras is your subject, were is your verb. Film cameras were, who, or what. Common. Common is a predicate adjective. And then popular is a predicate adjective as well, describing digital photography or just photography, okay? And number 9, my parents bought themselves a digital camera for Christmas. Okay, parents bought who or what? Camera. Camera is your direct object. To whom or for whom? So themselves. So themselves is an indirect object. Okay? All right, way to follow along tonight for homework. You don't have homework, but you should have done page 9, exercise 18. We will review those. Okay? We'll review those tomorrow, but make sure you guys do that for homework. Have those out, and then I will come and check them. For those of you in distant learning, please take a picture of page 9 in your workbooks and send it to me so that I know that you guys did it. But yes, we will go over that in a few, but today I kind of want to just review the first few parts of speech before tomorrow is a bunch of, like, all of the parts of speeches. Okay? Let's go all the way back to our first part of speech, which would be a verb. All right? The reason why that's our first part of speech, obviously you can start with any, but verbs are what we normally find first in a sentence. Okay, verbs. A verb is used to show action or state of being. Okay, these are the ones that do the action. They indicate that they're existing. They also link and they help out. So remember those about verbs. There are 2 kinds of verbs, which are transitive and intransitive. Okay, transitive means that the verb, or it requires a receiver of the action. So a verb needs a receiver. So in that example, the pitcher threw the ball. Okay, pitcher is your subject. Threw is your action verb, through who or what. The ball is your direct object. There is a receiver of the action, which is ball. So therefore, the verb threw is transitive. Okay? Intransitive, it does not have a receiver. Okay? So the ball sailed over the fence. Okay? The ball is sailing. However, there's no receiver of the action. Over the fence is just a prepositional phrase. Therefore, sailed is intransitive. There's no receiver. Okay? It's also linking or helping. Okay? Transitive, intransitive, linking, or helping. Linking is when it's just linking the word and the predicate to the subject. We kind of already practiced this with PNs and PAs with complements. Okay? Mr. Brown is your subject. Is your linking verb. Okay? Mr. Brown is who or what? He is the coach. So coach is your predicate nominative linking. So, predicate nominative is linking Mr. Brown to coach, and it is renaming the subject. So coach is a predicate nominative, therefore that sentence or that verb is linking. Okay? And when it's helping is when the main verb or this verb helps the main verb to make a statement. Okay? She can drive to work. Can is your helping verb helping the main verb of drive. Okay? Again, we said that verbs are used to show action or show state of being. They link other words to the sentence. Make sure you guys know what a verb is. One of the easier parts of speech to know and discern. Okay? Let's go with this over again. Nicholas plays basketball. Okay, Nicholas is your subject. Plays is your action verb. Nicholas plays who or what? Basketball. So therefore, it is transitive because basketball is your receiver. Okay? Nicholas plays well. All right? Nicholas is your subject. Plays is your verb. How does he play? That is an adverb describing your verb plays. There is no receiver, therefore it is intransitive. Okay? She tasted the cake. She is your subject. Tasted is your action verb. She tasted who or what? The cake. Cake is your receiver, so therefore it is transitive. The cake tasted delicious. The cake tasted, who or what, delicious. However, that is a predicate, that is an adjective or adverb describing taste because it's saying how it tasted, okay? So there is no, no, it's not describing taste, it's not an adverb. It's an adjective describing cake because the cake was delicious. Sorry about that. So therefore it is linking, okay? Tasted is linking the cake to delicious. All right? They are students. They is your subject. Are is your linking verb. Okay? So students is your predicate nominative. It's not exactly receiving action. It's students is renaming the subject. So therefore, are is a linking verb. Another one, they are in the classroom. They are in the classroom is, are is your linking verb. However, it's not exactly saying renaming or describing the subject, so there's no receiver of the action. Actually, that are is kind of used to indicate existence or state of being, kind of like what we saw that verbs are, so therefore it is intransitive because there is no receiver. Hopefully this is making sense to you guys and we're walking this through. Okay, they have bought a new car. That's kind of an indicator and a clear indicator already because bought is your main verb, have is a helping verb, so therefore it is helping. Okay, moving on to nouns. These are a word that name a person, place, thing, or idea. If you guys don't exactly, if grammar is not exactly your strong suit, make sure you're following along in your notes or highlighting what you guys need to study in your notes. Okay, hopefully we guys know what a noun is. That's another common thing in parts of speech. A noun is a word that names a person, place, thing, or idea. Person, Hannah, place, America, thing, cart, idea, things that you think of and can actually see, envision, things that you can hold, things that you can think of, those are nouns, okay? Nouns, common nouns, they don't exactly say which particular noun it is. Proper nouns, names of particular person, place, thing, or idea, which would be our names, or different things like that, honestly. Proper nouns begin with a capital letter, basically. Concrete nouns, these name whatever exists as a physical or material substance, something that you can hold, touch, see, different things like that. Abstract nouns is like what you can think of, which is a quality, state, activity, or general idea, like strength, okay? You can actually touch strength, but it is a noun because it is an idea. Or the quality, the state, different things like that. Collective nouns, that names a group or a collection, that would be team. There's one team, but there's multiple members on the team. A herd, there's a bunch, it's one herd, but it names a bunch of, it's talking about a bunch of animals in that herd, okay? Those are collective nouns. You would just use those collective nouns as a single, you would use a single verb with that collective noun, okay? Compound nouns, two or more words use a single noun. That's basically the two words that are describing something like president-elect, different things like that. Those are two or more words used as a single noun. First and last names are compound nouns. Hannah Coral, that is two or more words, two words, naming me, a single noun. So those are the different kinds of nouns. We said that substantives, those are noun equivalents, or another term used to refer to any word, phrase, or clause that functions as a noun or a noun equivalent. We saw this kind of in our exercise that we just said. I said that a gerund was being used as a subject. So gerunds, they can be used as a noun. Infinitives, phrases, and clauses, those are all substantives. Appositives, those are the ones that explain the subject. Those are also used as nouns, okay? One noun equivalent is a pronoun, which is a word that takes the place of a noun. He, she, we, they, them, different things like that. Pronouns are the words that take places of nouns. Pronouns have antecedents, which is the word for which a pronoun stands. Okay, the antecedent is not always stated within the same sentence, but if I'm talking about my husband Nick, he would be a pronoun, or he is the antecedent of Nick, okay? Different kinds of pronouns. There's personal, demonstrative, reflexive, intensive, indefinite, relative, and interrogative. Okay, so personal pronouns, these show whether reference is made to the speaker, which is first person, to the person spoken to, second person, or the person spoken about, which is third person. So if I'm talking, it's me, mine. And then if it's both of us talking in first person, it's we, us, our. If I'm talking to you, it's you, yours, your, okay? If we are talking about somebody else in third person, it's he, she, they, themselves, them, their, whatever, okay? So those are personal pronouns, okay? Compound personal pronouns, these have self or selves on the end. So myself, yourself, themselves. Compound personal pronouns have two uses, which is reflexive and intensive. Reflexive reflects the action of the verb back to the subject, okay, and then intensive is just used for emphasis. Mr. Smith himself did the work, or Mr. Smith did the work himself. They can defend themselves. They can defend her or what themselves. It's just kind of reflecting back to they, okay? Interrogative pronouns is who, whom, whose, which, and what. Those are just asking questions. Those are pronouns use as subjects. Okay, so who went to the store? To whom is this, do these belong? Whose jacket is that? Which way should I take? What are you doing? Those are different types of pronouns used as questions or interrogative pronouns. Demonstrative pronouns, these point out the person or thing referred to. This, that, these, and those. Those pronouns say, okay, this table, that wall, these chairs, those shoes, different things like that. Those are demonstrative pronouns. They point out what I'm referring to, okay? Indefinite pronouns do not definitely point out to persons, places, things, or ideas, and they don't usually have antecedents. So each, neither, one, everyone, everybody, no one, different things like that. Those don't exactly say this is the exact thing that I'm talking about. Each, neither, either, those are pronouns that I would use if I'm not exactly sure of what I'm pointing out. So those are indefinite pronouns. Okay, relative pronouns, these are used to introduce dependent clauses, who, whom, whose, which, and that. Okay, who, whom, whose, which, and that are basically, they are used as interrogative as well, but then remember we said how we determine which ones it is as the function in the sentence, okay? That's basically all the time that we have today. Let's go, you guys can put that away. If you guys have any questions, I'm here on campus. I know I can't be over there. I wanted to review as much as we could, but go ahead and just study those. We'll review the rest tomorrow, and we'll start with adjectives tomorrow, okay? Thank you.
All right, we are on 1.8. Welcome to Algebra 2. We're on 1.8, page 49. Please make sure you get out your books. Make sure you're following along. We're on arithmetic with radicals. All right, so we are on 8. 1.8. I'm just looking through things very briefly. Okay. Recall that when finding the root of a number, the principal root is being found. In other words, the principal root of a number is the root that matches the radicand in sign. For example, the square root of 16 is 4 because 4 squared is equal to 16. The square root of 16 is not equal to plus minus 4, okay? Because the sign of negative 4 does not match the understood positive sign in front of the square root of 16. This confusion arises because solving the equation x squared equals 16 by taking the square root of both sides yields x equals plus minus 4. This is only true because both plus and negative 4 can be yielded to to yield 16. This is different from the notation of the square root of 16, which is asking for the principal root of the principal square root of 16. Although principal square roots are always positive, the principal cube root can be negative if the number itself is negative. So, just very quickly, the square root of 16, whoops, I forgot I made the sticker. Oh well. The square root of 16 is 4. X squared equals 16 means x equals plus minus 4. There is a difference between the two notations. Okay, so make sure you guys pay attention to that. I can take the cube root of a negative, however. The cube root of negative 8 is simply negative 2 because you would have to cube negative 2 to get to negative 8. Okay? You just can't take the square root of a negative. Okay? At least until later on in the course. All right, so since not all radicands are perfect powers, whether it be a perfect square, perfect cube, etc., arithmetic with radicals involves a few properties that were introduced in Algebra 1. These properties are defined in the following table. So look with me, if you will, on page 50. Okay, so you have those properties. Let me see if I can zoom in because this thing is like really tiny for me right now. There we go. So we have the product rule for radicals, which says then if I have a radical of AB, I can separate it out into this radical of A plus, nope, not plus, times the radical of B. I can separate it out as much as I need to, which is extremely useful when we go through and say factor some things. The quotient rule says that I can take the nth root of a fraction and split that up into the nth root of the numerator over the nth root of the denominator. Okay, so we've discussed that one before as well. And then we have, if I have the bth root of x to the 8th power, this is fun to say, this is equal to x to the a over b power. Okay, and that's how we would word that. So we can make fractional exponents very easily. The above properties can be used when simplifying radicals. The simplification process may involve the removal of perfect powers from radicands, combination of like radicals, or multiplication of radicals. A radical in its simplest form has a rational denominator and a reduced index. The following table describes the various processes involved in simplifying radical expressions. So if you look at table H there on the bottom of the same page on page 50, we can remove perfect powers, okay? And so in this case with the square root of 32x, and as a matter of fact, let me go through and demonstrate how all that works. If I have the square root of 32x, well, I can go through and remove perfect powers there. So if I have 32, I can find all the powers of it. 2 goes into 32 16 times, 2 goes into 16 8 times, 2 goes into 8 4 times, and 2 goes into 4 2 times. This is prime factoring, okay? And so essentially then I have the square root of 2 to the 1, 2, 3, 4, 5, 2 to the 5th power times x. Well, again, keep in mind, this is the same as having 2 and 5 over 2 as the power, okay? So we can reduce. And so we can spread this out and say we have the square root of 2 squared times 2 squared times 2x. Okay, then when we take the square root of 2 squared, we get 2. The square root of 2 squared gets to be made 2. And then square root of 2x. This leaves me with the 4 times square root of 2x. Alternatively, if we don't want to do all the extra writing, we can come straight down and just know 2 goes into 5 2 times, so I'll have 2 squared. with 1 left over, and the leftover stays inside. 2 squared then becomes 4. Okay, whichever way helps you to remember it. Then we can combine like radicals. As long as I have the same thing in the radical on either side, we can do that. So 3 times the square root of 2 plus 4 times the square root of 2 would equal 7 times the square root of 2. Notice we do not add what's inside the radicands. We treat them like a variable. We can combine them just like we would combine like terms. However, I may have to make them into like radicals. For example, if I have the square root of 12 plus the square root of 27, then I can get, all right, well, if I take 12 and finish it, or simplify it. 2 goes into 12 6 times, 2 goes into 6 3 times. I've got a pair of 2s, so that can come out 2 square root 3 plus, and then we can take 27. Do I have enough? Okay, as long as I stay there. 3 goes into 27 9 times, 3 goes into 9 3 times, so I have 3 times the square root of 3. So I have 2 times the square root of 3 plus 3 times the square root of 3. That gives me 5 times the square root of 3. Okay, so I can go through and do that, but I have to have like radicals. Multiplying radicals, again, we can just multiply the insides as long as we have the same index. We do need to rationalize denominators. Again, for example, if I have 1 over the square root of 3, this will equal, let me show the multiplication. We multiply the top and the bottom by the square root because we cannot have square roots in the denominator. So we have the square root of 3 over 3, and that's how we would represent that. Hopefully that looks familiar. To rationalize denominators that are not necessarily a friendly power, so for example, if I have 1 over the cube root of 2, well then I need to do the cube root of 2 squared over the cube root of 2 squared, so that way my powers match and my radical goes away. So when I do that, I get the cube root of 4 over 2. Okay, and that would be the simplification there. Okay, we have to make up the difference, so when we multiply the insides, the power matches my index, and I'm just left with what's inside. If we have 3 over 1 minus the square root of 5, we can multiply by 1 plus the square root of 5 and 1 plus the square root of 5, and this will allow me to rationalize this one because this will give me the difference of squares. So I will end up with 3 times 1, which is 3, plus 3 times the square root of 5, all over. Well, I am being forced to have the difference of squares, so I have 1 squared, or 1, minus the square root of 5 squared, or 5. And so that would just give me 4 in the denominator, okay? And that would be how that works there. It was 1 minus 5, so negative 4. Okay, 1 minus 5, so negative 4. Sorry about that. Finally, we can reduce indices. Okay, if I have the 6th root of 8, well, 8 is 2 cubed. So I can write this as 2 and 3 over 6, which is equal to 2 and 1/2, or 2 to the 1/2 power, which is equal to the square root of 2. And there, now it's simplified. Okay, I can do the same thing if I have the 9th root of x cubed. Well, then I can put x to the 3 over 9 power. Well, that equals x to the 1 over 3rd power, which means I have the same thing as the cube root of x. Okay, so make sure you reduce your indices. Okay, hopefully all that's review, and we're going to move right on. On page 51, if we were talking about the addition and subtraction of radicals, well, we use like terms, okay? And like radicals have the same idea, so it has to be the same thing inside the radicals for us to do it. We may have to simplify first. So let's look at example 1.8a. Okay? If I look at example 1.8a and part A, I'm going to see that I have 2 times the square root of 7 minus 5 times the square root of 7, and that's going to equal negative 3 times the square root of 7 because everything's already like terms. I didn't really have to think about that one too hard. But then on B, let's say I have 15 times the square root of 3 plus 4 times the square root of 12. Well, one thing to note here, I can't add those directly. I cannot just say 19 times the square root of something. What would I put in there? Okay. However, let me see if I can simplify 12, and I think we can. So if I have 12, and I'm going to simplify it. 2 goes into 12 6 times. 2 goes into 6 3 times. Okay. Well, I've got a pair of 2's. Those can come out. So 15 square root 3 plus 4 times 2 times the square root of 3, because this is by itself, it stays in the radical. Okay. So now then I have 15 square root of 3 plus 8 times the square root of 3. And so 15 plus 8 is 23. So I'm left with 23 square root of 3. That's as simplified as we can get. All right, so those are our answers. If I look at part C, we have the cube root of 625 plus 4 times the cube root of 320. All right, so the first step, every time you see something like this, is simplify your radicals. So I have 625, I'm going to prime factor. So 5 goes into 6 once, with 1 left over, so 5 goes into 12, because we bring over that 1 that was left over. 5 goes into 12 2 times, that leaves a 2. 5 goes into 25 5 times. 5 goes into 12 2 times with 2 left over. 5 goes into 25 5 times. 5 goes into 25 5 times. Okay? So I have a set of 4 5s. Well, a set of 3, because I have to match my index, can come out. So 5 times the cube root of 5. Notice that I'm only pulling out one representative. I'm taking the cube root of 5 cubed. Okay? So that's just 5. Then plus, and then now I have to do it with 320, and there we go. Got to make sure I'm under me. All right, so 2 goes into 3 once with 1 left over. 2 goes into 12 6 and 0. 2 goes in here 80 times. 2 goes in here 40 times. 2 goes into 40 20 times. Oh goodness, this is long. 2 goes into 20 10 times. 2 goes into 10 5 times. Oh, thank goodness we're done. All right, so we need pairs of 3. So there's one set, or pairs of 3. We need groups of 3. There's another group of 3. So I have 2 times 2, because those each came out, times the cube root of 5. So I end up with 4 times the cube root of 5. 5 plus 4 is 9. So I have 9 times the cube root of 5. What? Oh, sure. Okay, well, this was toward the end. One problem. This 4 needs to come down. So we have 4 times 2 times 2 times the cube root of 5. So let's go through and simplify first. My bad. So 5 times the cube root of 5 plus 8 times 2 is 16 times the cube root of 5. There we go. That's why things didn't look right. 5 plus 16 is 21 times the cube root of 5. Okay, always make sure that your number doesn't get lost. It's very easy to do, as I just demonstrated. Make sure that you get everything included. But that would be our final answer. Let's go ahead and go to part D. In part D, I am given the 5th root of a to the 10th, b to the 12th, plus the 5th root, goodness, of 32x to the 15th, y to the 20th, and b squared. Okay, so one thing at a time. Let's go ahead and take care of this one piece by one piece. 5 goes into 10 2 times without anything left over, so a squared comes completely out. 5 goes into 12 2 times, but this time with 2 left over. So we have the 5th root of b squared on it over here. Now, 32 is 2 to the 5th. Okay, so and if you didn't know that, we could just have gone over here. 2, 16, 2, 8, 2, 4, 2, 2. And look at that, there's 5 2s. Okay, so 2 can come completely out. 5 goes into 15 3 times, so we have x cubed. 5 goes into 20 4 times, so we have y to the 4th. And finally, there's nothing I can do about the 5th root of b squared. It's just stuck there. But at least now I have like radicals, so we can simplify. So I have a squared b squared plus 2x cubed y to the 4th times the 5th root of b squared. Unfortunately, I don't have other like terms, so that's as far as it can go. Let's talk about multiplying radicals. When 2 radicals with the same index are multiplied, write the answer as 1 radical, with the radicand being the product of the 2 original radicands. Remember to remove any perfect squares, leaving the answer in reduced form. However, when 2 radicals with different indices are multiplied, use the LCD of the fractional exponents to find the common index. Once the indices are the same, then you can multiply the radicals. And you may have gone, what? Let's look at example B. All right, because this is one of those things that's a little easier to just do. All right, so let's say I have the 4th root of 5 times the cube root of 2. Okay, well, there's no real way to handle this naturally. We have to go to fractions. So this means I'm going to have 5 to the 1/4 power times 2 to the 3rd power. Now I can get things in like terms, okay, or like denominators. So 5 can go to something over the 12th power. 4 goes into 12 3 times, so we're just making equivalent fractions. That's all we're doing. So we get 4 to the 12th, which means then, cool, I have the 12th root of 5 cubed times 2 to the 4th. Now I can go through and start simplifying. 5 cubed is 125, 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. So I have 125 times 16, or when I go through and multiply all that, I get 2,000. Whoops. The 12th root of 2,000, okay? That's as far as we can go. There's no common factors. We already went through and checked, so that was it. Okay, that was part A. Part B. We were given the cube root of 4 times the square root of 6. Well, again, then I'm going to have 4 to the 1/3 power times 6 to the 1/2 power. Well, then I'm going to have 4 to something over 6, so that will be 2, times 6 to something over 6, which will be a 3. And now I have the 6th root of 4 squared times 6 cubed, which then means I can already, what? Okay, we'll take care of all this at the end. Okay, which then means I'm going to have the 6th root of 16 times 6 times 6 is 36 times 6 Why is my brain freezing? 21, that's 216. Then we take that times 16, and then we have a big problem. Or we can go through and start factoring things out once we see it. Okay? So, real quick thing to notice, okay, 4 squared is 2 squared squared, or 2 to the 4th. Okay? And then 6 cubed is 2 cubed times 3 cubed. Okay, this is why the book shows it this way, because otherwise the numbers get really heavy really fast. All right, well, these parentheses aren't doing anything, and through the associative property, I can go ahead and combine these 2's. So we have the 6th root of 2 to the 7th times 3 cubed. You have to double check for this. Okay, 2 to the 7th is bigger than the 6th root, so I can pull out a 2. So I'm going to have 2 times the 6th root of 2 times 3 cubed. That's as far as we can go. So 2 times the 6th root of 2 times 3 squared is 9 times 3 is 27. So 2 times 27, which is equal to 2 times the 6th root of 54. Okay, and therein lies our final answer. Let's look at example C. In example C, we can go through and distribute. We can go through and multiply just like normal. So if we have example 1.8c and part A, we have the square root of 2 times 1 minus the square root of 2. Well, this would still multiply as the square root of 2 minus the square root of 2 squared, or 2. Okay, so that's it. For part B, if I have, maybe parentheses weren't the best choice here, but oh well. 5 minus the square root of 2 times 3 plus the square root of 2. Well, I still go through and FOIL it. So 5 times 3 is 15. 5 times square root of 2 is 5 times the square root of 2. 3 times negative the square root of 2 is negative 3 times the square root of 2. And square root of 2 times square root of 2 is 2. And we have a negative, so negative 2. So 15 minus 2 is 13. 5 minus 3 is 2. So 13 minus 2 times the square root of 2. Why do they have plus? Oh, 5 minus 3 is positive. Durr. All right, part C. We have x minus the square root of 3 times x plus the square root of 3. Whoops, that should be the square root. Ugh. There's no forgiveness on this pen. All right, so we get x squared plus x times the square root of 3 minus x times the square root of 3 and minus 3. Well, then we just get x squared minus 3 because the insides go away. So that was it. Okay, that's multiplication with radicals. Again, you guys have all these in your book. That's why I'm not giving you guys time to write them down. You guys have them there. Let's talk about the division of radicals. How much time do I have? Let's see here. Not a lot. So, all right, we're going to do this in 2 parts. I didn't originally plan to, so that means your lesson plans are off. But I'll adjust those as needed. So for tonight's homework, you are doing numbers 1 through 32 in practice. Where's my pen? Numbers 1 through 32, and that's just green. Yeah, that works out fine. Yeah, that'll be good. Oh, right, I moved to the quiz, didn't I? Quiz 4 is tomorrow over 1.7. Quiz 4 over 1.7 is tomorrow, and then we'll finish out 1.8 with division. So distance learners, you'll get information about that quiz shortly. And then Chapter 1 review will be due Monday, and your test will be Monday and Tuesday over Chapter 1. Okay? So we'll finish up the section tomorrow after your quiz. Chapter 1 review will be due Monday. It says Friday in the lesson plans. It's going to be due Monday now. I moved that. And then your test one will be Monday, Tuesday of next week. Again, distance learners, you'll get information about that later. So tomorrow will be 1.8, day 2. And then Thursday, Friday will be your chapter review. You'll have time to work on that in class. Quiz 4 is tomorrow over 1.7. And again, test 1 over chapters 1 will be Monday and Tuesday. So you guys are doing numbers 1 through 32 green in 1.8. If you have questions and you're in the Distance Learning Center, I'll be down shortly. Otherwise, you can text and email me. That should be it. I'll see you guys tomorrow.